The topic for tonight's DevStaff meetup is about Dart and Flutter. We will start with the DevStaff welcome and intro presentation. Later, Efthymios Sarbanis will talk us about Flutter and what is it and why should I care. And then Ulbeg, excuse me if I don't pronounce it correctly, we talk about Flutter, Widget, and App Lifecycle. First of all, a few of our sponsors. Tonight is JetBrains, which will offer us 2 JetBrains ID licenses. We will be raffled at the end of the tonight's meetup. A link will be sent later to chat, so you will be able to run the raffle process. Best Price, the known company here in Crete. Yodek, a company about digital signage, if I remember correctly. And last but not least, Ferlo, a new company here in Crete, an old company that now has opened a department here in Crete as well. So everyone can sponsor DevStaff we're using Open Collective. All of our sponsorship are open. You can go there and take a look about the sponsors of DevStaff or become a sponsor as well. So first of all, welcome to everyone for the which are first timers here in the DevStaff meetup. I'm Michalis, as I said before. DevStaff is an open community that started back in July of 2015. And its goal is to bring people who are passionate about technology and software close together. So we have more than 1,300 members. And we usually talk about as DevStaff as our community, your community. But let's see what do we mean with the term community. So we are not we're an open community. We don't have representatives or any other legal formation. So everyone is equal in this community. We have no titles, no presidents, etc. No elections, of course, and we are open as open source. But what's the catch here? As open software, we need active participation from people. So how can someone participate in DevStaff? First of all, someone can join us on Slack, where we talk about various things almost every day, and some topics become really hot around developers, around many issues. Second, someone can open a PR in our GitHub repo, where to propose things, to change things, to discuss things. And finally, everyone can participate in the org team meetups, which occur almost every month. They are open to everyone. They are announced at meetup.com as this one meetup, so everyone can join us. As about meetups, as the one we are today, they happen every second Thursday of each month, and everyone can attend. You also can suggest topics, suggest speakers. A form will be posted in the chat later on that you can fill it and suggest a topic, suggest a speaker. We welcome feedback from everyone. And finally, vote about the topics you want to see on DevStaff. We used to do this a few months before, which we send a vote through meetup.com, where we had some topics and everyone could vote. And the org team had to find speakers if possible, and present these topics. So the first thing you can do is to join our community in the meetup.com, where you can join the group and then get notified for new events, for a few things about we announce through meetup.com. Then you can RSVP to some meetup, send feedback to us, and of course, join these meetups. So apart from the meetup.com, we maintain a repo where most of the things for our community. We can there find a lot of information about how things work, about hack sessions in the past, about issues that have been discussed there, or go there, open an issue and discuss it with other people as well. As about the meetup topics, as I said earlier, you can propose new meetup topics to the organizational team by completing the form we will share to you. And the org team is responsible to find speakers if possible and select the most promising and prepare and the next meetups for the upcoming months. So there we need your help. Just propose a speaker you know or watch some elsewhere. It might include even you. So apart from the meetups, we occasionally have some hands-on event. These are mainly organized by DevStaff members. Hack sessions are hands-on events where people learn together through group learning, sharing experiences. In the past, we have done a lot of hack sessions. Some of the examples here, Docker, Tor, HashiCorp, etc. You can propose a hands-on event on Slack or even GitHub. Just open a PR there, an issue in the GitHub, and let's discuss it in order to find more people to facilitate it and so on. Apart from this, in the GitHub repo, we'll also maintain a job board. You will find it under the jobs, the README and MD, where everyone can open a pull request, and we will merge it just to keep the people notified. You can start the repo and get notifications about any new openings. And it's pretty crowded over there if you get in the list. Oh. What? I just opened the link. What happened? Oh no. Okay. And last but not least, we have a code of conduct. It's written down in the GitHub repo, but we just be civil. Finally, there's a time for announcements. If anyone wants to share something with us, with the community, before we start with the presentations, we give some minutes. Please open your mic and
Michali?
Yes, hi, Alex.
If you allow me for a second.
Sure.
Today there will also be a book to give in the raffling process. There is no sponsor, it's from me. So whoever is interested for the book, the title is Web Scalability for Startup Engineers. You can Google it. And that's it.
All right, thank you. Thanks a lot, Alex.
Yeah, the winner just have to send me his some shipping information and I will send it to him. That's
okay, all. Okay, we'll just collect the emails and we will see how it's going then. Please just paste the book on the chat so everyone will be able to see it. So if there's no announcement, any other announcements, we can start with the talks. I'll stop share. So Efthymios is the first one. Nice.
Right. Hi, everyone. So I'm Efthymios and like to thank the Meetup for having me to talk about Flutter. Before I start, though, it would be nice to see how many of you have a knowledge of Flutter, or at least like mobile development, with a maybe virtually show of hands. If you can do that, so then I can understand, the crowd. Okay, I see one, and I know that one. So, all right. Okay, all right, two. So that's a perfect talk for, oh, all right. So I get a couple of you, I see. All right, so I think it's a perfect topic to introduce this framework that Google built, which is called Flutter. So in the talk, I don't have code and have a lot of code, although we have one demo, very short. I want to focus on what it is, what's the history behind it, how it is architected, and what are its strong points. So a little bit about me. I'm a full stack developer, actually Flutter developer for now, in a startup called Ping Pong, and we are developing a asynchronous communication tool. You can find it in getpingpong.com, and actually today we just released our production. So the product is live from today. You can either scan the code or go to the link if you want to try it out, and we'll get a lot if you get your feedback. And I am also the organizer of the Flutter Greek community. I've been involved in Flutter since before its version 1. And just to give you an idea, just last week, Flutter entered version 2.0. I have created a couple of open source libraries for Fluttering, basically some patterns, common patterns that I saw. I just extract them into libraries. And we have a meetup, and we haven't had a lot of meetups just because I'm a sole organizer, and whenever I get busy, I don't have time to organize the meetup. But generally speaking, I think we're going to pick up pace from now on. I am also a contributor in Flutter. I have landed a dozen of commits there. And I am GDE for Dart and Flutter. GDE stands for Google Developer Expert. Yeah, that's about me. That's enough about me. So what is Flutter? Let's start with a bit of history. Those 5 points are the 5 major points in the history of Flutter and milestones that they hit. So this started off as an experiment in Google by Ian Hickson and Eric Snyder, I think. Maybe I butchered his name. So what they did is that they took Chrome, they forked it, and they tried using a stripped down version of Chrome and JavaScript to create a cross-platform mobile solution. But they quickly hit the threshold that Chrome and JavaScript allowed for them to do what they wanted to do, which is build a cross-platform framework. So what they did next is what they actually is one of the best decisions I guess they did. So they kept Skia. Skia is the rendering engine behind Chrome. So they kept the rendering engine so they could draw on a screen, and they switched from JavaScript to Dart. So after they did that, they never looked back because this was a really nice match for them. I will get in depth with what where is Skia and what's Dart and how it is so architected, but this is just a brief history of it. So the problem they tried to solve, as I mentioned, is that they wanted to build to develop a mobile, but if you see, I crossed out mobile, which is now multi-platform applications with a single code base in a performant way, and performance underlined for a reason. So I crossed out mobile because just a couple of months ago, this was the case. All the other platforms were back. But since last week with Flutter 2.0, Flutter for Web and Flutter Desktop also took some major advancements in their development. And we'll get back to what Flutter for Web and what Flutter for Desktop is. So the problem, the initial problem they tried to solve is that if you want to have presence in the both iOS world and the Android world, if you had native apps, you have to maintain two code bases, which means that you have to constantly port between the two features, port bugs, or deal with certain irregularities that each platform provides or not, and restrictions, of course. So you have two sets of you create two sets of problems to produce like a product. So that's the major problem. And Flutter is not the only framework that tries to address that. But we'll see next in the architecture what's the difference between Flutter and all the other solutions. So the common approaches is like what Ionic uses, which is like a web view. So you program in JavaScript, TypeScript, sorry, using frameworks like maybe Angular or whatever. And what Ionic does, it wraps that in a web view, and it uses a bridge to communicate with the native services. And well, while this is very practical and you can get like, maybe you can reuse a lot of things that you might also have in a web app, it's not that performant, and it creates a lot of problems basically when you want to skin something or to change the way that something looks on the screen. So that's the wrappers approach. And there is the bridging approach. So what bridging does is that you have your the platform, and you have like the native code, and you create a bridge between the platform and your native code. The thing is that these OM widgets that they say, so what this does is that it uses the platform's service and the platform's API in order to draw the application to the screen, which means that if you're running it, let's say in iOS, you have to use the iOS's API in order to draw things in the screen. And this, of course, creates some problems. It's not that you cannot easily have like custom widgets there. So this approach is something that React Native uses, and React Native is the biggest one out there. So that's the two common approaches. But what Flutter does and what distinguishes it from what the other approaches are doing gives it its performance. So Flutter draws directly, so it takes over the screen and draws directly to the screen. So it takes over the screen and draws the pixel itself. So it doesn't need to interface with any native API in order to draw anything. And this, of course, is more performant because you eliminate a layer and you can have it on the screen pretty fast. And also, the customizability of it is like, it's never ending. I mean, you can do whatever you would like to do because, as I mentioned, it takes off the screen and it paints the screen. What this means is that Flutter compiles the application, the code that you're running, it compiles it into an ARM binary. So this binary then is sent to the platform and it runs on the platform. But it can do only that much. What I mean by that is that, of course, you can draw on the screen, but let's say that you want to have like location service or Bluetooth or some sensor. All of those needs to be interactive with the services that the platform provides. And of course, this cannot be done if directly from the binary. So what they're using is platform channels. And platform channel is a way of communicating with native code, with, let's say, platform native code, because Flutter also is a native code because it's an ARM binary. So it creates channels that communicate bidirectionally or unidirectionally. It depends on what you want. Both of the options are there. So you can open up a channel that communicates to those services. How this is done, I will demonstrate later on. So this is basically what Flutter does that's different from all the other, let's say, cross-platform solutions. So how Flutter is architected? It used to not have this embedder layer. This is something that's just added with Flutter 2.0. But one of the most famous Flutter talks is a talk by Ian Hickson, which is like the creator of Flutter, that is called the Mahogany Staircase. And what Hickson is saying in that is that Flutter is a layer upon layer upon layer architecture. What this means. So let's forget about the engine and the embedder. I will get to that. Let's focus on the framework itself, like right here. Okay. So you have this foundation library. From this foundation library, everything up above that depends on the foundation library. Foundation library are utility classes or methods that could assist someone to, let's say, find a spot or a coordinate on the screen, or maybe draw something very basic. Above the foundation is those libraries: animation, painting, and gestures. So those libraries use the foundation library in order to register gestures, paint something on the screen, or animate something on the screen. And rendering then uses gestures, painting, and animation in order to render the actual widget on the screen. So rendering actually uses all that is above, beneath it in order to, what it says, render something on the screen. Widgets is an abstraction above rendering. So widgets uses rendering to render itself on the screen. And then we have material and Cupertino, which are flavors of widgets. You know, the look and feel is different and something like that, which use the widgets library in order to have a custom appearance. And that's the Mahogany Staircase, actually. This is like the layered architecture of Flutter. And the engine itself is written in C, C++, so it's native code. And this is actually very low-level things that need to happen in order to compile and to use the screen itself. The embedder is something that is added recently. It was added recently because initially Flutter was for mobile only, so they didn't need to have embedder. Everything was in the engine. But now, because Flutter also branches out to web and branches out to desktop as well, they abstracted this layer here in order to facilitate the different platforms that a Flutter application may run. So in theory, you could write a simple app, let's say, and could have it run in Android, iOS, the web, desktop, and like when I say desktop, I mean Windows, Mac, and Linux. There are some quirks in desktop. It's not there yet, but web landed on stable channel. So web is in beta phase, let's say. And that's the architecture. I won't bore you more on that. And this is another major selling point for me. So as I told you, Flutter communicates via bridge in order to get some services like location service or Bluetooth or whatever the device may offer. But in order to do that, you have to communicate to something that actually understands, understands the native API. So what they are doing is, as I told you before, they're opening up a channel between a native code here and here. And when I say native here, I mean native iOS code, Swift or Objective-C, and more native Android code here like Kotlin or Java. So when you create a project in Flutter, and you will see that later on, you also create two more projects, one iOS project and one Android project. And those projects are there to facilitate that. So let's say I want to check the location of the device, then I have to communicate to the device itself. And in order not to break the paradigm of compiling it into an ARM binary, they open up a method channel to a native code. Then you can get all those services, or you can even run it. And because of this, you can actually start running Flutter widget inside your current, let's say, Android or iOS application. But don't worry, you don't have to do this all yourself. So you don't really have to write all the code for getting various things yourself. This is like an old snapshot, but it's like all the different plugins. So this is what's called a plugin. A plugin is whatever we need to get from a native platform. We use a plugin. So we have plugins for pretty much all the major things that you might want, like you can read it yourself, I guess. There's no point in reading them, but that's something that comes. It doesn't come with Flutter, but their libraries are there and they're maintained by the Flutter team.
Efthymi,
yes.
Can you go one step back?
Sure.
So, for example, this Google Maps Flutter library allows your application to interact with the Google Maps application on the platform.
It allows you to interact with Google Maps. I haven't used it, but I'm not sure how it's doing it. You can actually embed into Flutter a native view. So what I think they're doing is they're doing just that, embedding native views. But the thing is that because you have method channels, you can actually have method channels over your native API and then communicate via Dart code to your native API and have everything in your Dart code. Basically, that's what every plugin does. That they do very minimum things. Just, okay, you need to call a certain function in the platform, then you expose that function through a method channel to Dart, and you use it in Dart. That's basically what they're doing. I don't know if I answered your question.
I'm not sure either. What I was asking is, I can understand that the camera plugin allows you to interact with the platform's camera.
Yeah.
But I was wondering if the Google Maps Flutter library, for example, allows you to interact with what? With the Google Maps application that is installed on the platform, or it is just a view and you have to communicate with Google Maps? Ah, okay.
Yeah, it's a view. They are not opening up the application. In order to do that, you just use like something like URL launcher, and you have like a custom schema, and you open up the other app. That's pretty simple to do. But in order to interact with maps, so you need location, you need a lot of like sensors, maybe even the compass. So that's all given to you to use in Dart, but it's in your app. It's not the Maps app. All right. Cool. So a little bit of architecture. This is going to be presented by Ulbeck, as far as I know. So I will just touch upon that. So how do you build a app in Flutter? You basically, what you're doing, you're building a widget tree. So you have like a widget within a widget within a widget. So you have like a root widget, and you have like a whole tree underneath it with widgets. And every widget corresponds to like a screen which has like components in it, and all of that is creating a tree. And you have two types of widgets. We have a stateless widget and a stateful widget. The difference between the two is that in stateful widget, it can preserve its state. So a stateless widget is something that does not change. So if you want to change it, you just eliminate that and create a new one. But for stateful widgets, you can it stays in the widget tree for a longer time because it prevents the state. But this will be demonstrated, I think, with Ulbeck's presentation. So I won't get too much into that. Okay, demo time. So this is an application I prepared earlier because I don't want to waste time in running all the different things. So basically, you want to create an application for Flutter. You have, of course, to install Flutter, and you can just run Flutter create and the name of the app that you want, maybe let's say counter in our situation. This will create a very basic app. When I mean basic, I mean very, very basic app, just so that it can demonstrate basic things. And I will get to that. I'm just running the app, so I'm just hitting run here. This is a plugin in VS Code that can help you with all those things. In order to do that in the terminal, you can just run Flutter run, and it will just run, pick up any devices that you have, including emulators. If you have like only one open, it will automatically open your app into that. Otherwise, it will prompt you to select in which device you want. Because it takes some time, so if you see, it's running Xcode build. So as I told you before, this is what you get when you run Flutter create. You get lib. This is Dart code. This is the app. And we'll get to what it does. But I want to turn your attention to iOS and Android. This is what I was telling you about, creating 2 more projects. So if I want to include in my app here something that needs, let's say, location services, then I either install a plugin using this. So there is a dependency management tool called pub, and with pub you get this pubspec YAML file, and you can put your dependencies here, and then you can run Flutter pub get, and you get the dependencies, and then you can use them inside your app. So iOS and Android are here, and if I wanted to have a very, very small thing needs, let's say, to have in my app, let's say that my app is a very basic app that runs over an API, then basically I would only want the native plugins here if I want to offer, let's say, a social sign-in. because social sign-in needs to have certain permissions and all that, you need to not create, but use a plugin, because there are plugins for that. But if you have just a basic like API where you register your users yourself and you sign in there with yourself and you get like a JWT token, then you go ahead and do all your API calls with that token, you don't really need to write anything in native code. You can just write everything in Dart, and you have a single code base. With this single code base, you can create iOS and Android apps. So the selling points for Flutter, for me, are three. First of all, you eliminate a lot of code that you need to be duplicated in iOS and Android. What you keep in iOS and Android is only code that you really need in order to do something with the platform. All the other code is common code, and it's in Dart. Another thing is that yeah, I kind of lost my my thoughts there. Okay, so yeah, the other thing is that because it takes over the screen, so whatever you see here in the screen, the simulator, it's been painted by Flutter. It's not painted by the platform, which is iOS in this situation. So if you want a basic app above an API and you want to have it to have like both platforms for free, you just use a Flutter and you use Dart, and you have a single code base, and you can create both of those and actually ship them to the stores and have your clients download them. So this is a basic app that you get when you create an Android. And so what it does is just, I click here and it just increments. But another thing is that why the Flutter team chose Dart is that Dart can come with two compilers, both an ahead of time compiler and a just-in-time compiler. So when you develop, they're using the just-in-time compiler. But when you build, they're using the ahead of time compiler. So let's say when you develop, because they're using just-in-time compiler, if I go over here and okay, this is the title, and I want like to change the title, I don't know, like that. Whenever I save that, it will hot reload the app. Okay, actually I have a problem with my simulator, but I can hot restart, and it's there. I mean, I didn't have to recompile everything and then upload them to the screen and present it there. Okay, but thing is that I missed how hot reload because of the issue. So let's say that I write this button and I save. Yeah, okay. Sorry, that's the demo daemon. But I can hot restart. Hot restart is that I restart the app. I don't have to recompile it because the just-in-time compiler is there. So the just-in-time compiler will pick all these changes. I think with Ulrich would have better chances than me to illustrate that. But okay, so just believe me. So if I go here and I don't know, remove that and save it, hot reload. Yeah, hot reload doesn't work for me today. I don't know. Anyway. Okay, so it's the thing is that because it can do that, can do hot reload and hot restart, the development time and the development lifecycle is very, very quick. So you can have a setup as I have it here and code away your app, and you can immediately see the changes here. And the other thing that is a selling point is that it gives you the opportunity if you want to do something in, like you have a Init service. For instance, we in Ping Pong, we have a video recording, okay? And we have created our own plugin for video recording, but we created a native code for iOS and Android only for that. All the other code that has to do with navigation, going here, there, fetching information, all that, is in one place, is in Flutter. And the only thing that is duplicated, like quote unquote duplicated, is the thing that we really need to have it there. And that's a major selling point for me. Okay, so if we go a bit here, I will just browse through the code. You'll see a lot of code if you look at that, but let's browse through the code. So we have a main method, and in main method, we use this function to run our application. As I told you before, there is a widget tree, and this my app is the root of all widgets. It is a stateless widget, and it has this build method. The build method is called whenever the widget tree is built, and you have to see think of a widget tree as in object-oriented classes. So widget tree is the expression, and this gets compiled to an element tree, which is like the instances. But this is done, you don't see that happening. So behind the scenes, Flutter maintains 3 trees. Maintains the widget tree, which is what you have expressed in code, and then it creates an element tree and a render tree. But I'm getting in too deep with this architecture, and maybe it's a lot to absorb. So I will just go on here. So you have this material app, and in the material app, you have a theme, and you say your primary swatch want to be blue. What will happen if I have that as red? And if I hot restart, all the accents are red now. So there is a theming ability in the app. And home is the initial home page, and this is the home page, which is a stateful widget tree and a stateful widget, and the stateful widget has a state, and this is what is maintained. So here I maintain the state of the counter, and when I increment the counter, I set the state with a counter ++. And so if you see here in the tree, I'm not going to pay attention to all of the widgets, but basically there is a button, and the button is here, the floating action button. This floating action button is this, it's a representation of this button. So you can have on pressed. So when you press it, you can increment counter, and there is a tooltip. The tooltip is because of web. This is what's new here. So we could run this in a web browser if we wanted to, and it will run just as in an emulator. And we have an icon and an icon add. I can change the icon to whatever I want, like I don't know, let's say, yeah, that's okay. Let's have an alarm, and of course it doesn't hot reload because of my problem, so I hot restart. But the icon, you can just change the icon that easily. So basically, that's what you get out of the box when you start a fresh Flutter project. But I'm running out of time, so let me just resume here. So what you saw over there, this is a representation of how the state was maintained. So you have the widget tree. In the widget tree, you said that I have an item counter widget, all right? And the item counter has a name, which is Tom. And they create a text, and Tom has 0 counter. In the element tree, this widget tree, which is a stateful widget tree, in the element tree, you get a stateful element and the state. Here is the state. So everything here can change, but this will always be here and pointing to the right tree. So when you want to change the state, like increment the counter, then the stateless element would be replaced, but the stateful element will not be replaced, will stay there. And Flutter goes above and beyond to do as less of replacements in the element tree as they can do. The widget tree is another thing. So the widget tree is very, let's say, cheap computationally. You can, replace whatever you want there. but the element tree and therefore the render tree is more expensive computationally. So they try very, very hard not to replace, not to remove from the element tree if they don't have to. And that's why the state remains there and the counter also increments without rebuilding. So why should I care? And I think I have a bit of time. So the benefits: you have full control over the rendering stack. If you wanted to, you can draw on the platform canvas, but you don't have to do that because we have the material and the Cupertino libraries that actually implement those the Cupertino and the material specs. So you have widgets out of the box. But if you wanted to, you can create your own. You have a reactive use with no bridge because Flutter draws directly to the screen. And there's a great development experience because of hot reload that I couldn't demonstrate here. I'm sorry for that. It's a smooth, fast, smooth, and predictable UI, meaning that because you have a widget tree, the UI is always going to depict this widget tree. It will not, depict something else that you have to do or something very fancy. It's just that. You can deploy to multiple platforms, just one code base, as I mentioned. If you have a very simple app that runs over an API that has its own sign-in and all, let's say, capabilities, you don't even have to use any plugin. But if you have to, there's the ability to use native plugin for like niche cases, or if you want to have your application have more functionality. And also a lot of big corporations, this is like a deprecated list. There are a lot of more added. So Google uses it for the Google Ads applications into Flutter. The Google Pay application is in Flutter, and a lot of other Google applications are written in Flutter. Toyota actually are using it for their embedded multimedia center because Flutter, as I told you, is compiled into ARM binary and can take over the platform screen and draw into it. It's really good for embedded, let's say, application. eBay uses it for the car application. Square uses it. New York Times. You can check to the showcase here. We go to the showcase. We'll see a lot more. But I don't want to bore you with that. You can just go over there, like flutter.dev showcase, and see who else uses that. And yeah, so there is, for resources, you can scan this QR code, you will taken to a curated YouTube playlist. If you want to know more about, Flutter, it's very basic things that you can know here and you can understand here. It is fallen behind. This a bit of update now with Flutter 2.0, but we are curating it. If you want to join the Crete community in order to learn more and interact with other people that maybe have a problem we want to solve it, you can always go to find us in our Slack or in our Meetup, and we also have a Twitter. You can scan those codes as well to be taken to those. And I don't know if I have time for questions, but if you have any questions, I'm would be very happy to answer them.
Thank you very, very much, Ephthimis, for this presentation. It was awesome. I would just recommend, if you all agree, to move on to Ulukbek because it's too late for him, and then stay as long as we want for questions for both presentations. Is that okay?
It's okay for me.
Okay. Thanks. So, Ulukbek, the stage is yours.
Hello everyone, can you guys hear me well?
Yep.
Okay, let me share my screen. Hi, everyone. Thank you for inviting me to this meetup. My name is Ulukbek, and I would like to talk to you yet another. I would like to present you yet another talk about Flutter. So in the previous talk, we saw what Flutter is, what it is capable of. In this talk, I would like to give you just a brief overview. What are the widgets and what is their life cycle? What are they like? What are they inside? Just we will look a little bit under the hood. So before we start, a little bit about me. So I'm talking to you from Tashkent, and you guys are in Greece right now. So just for you to visualize, this is the map, how far I am. And I would like to take this opportunity to invite you all to Uzbekistan. If you have time, you should visit this place because it's a great place with like historical cities, delicious food, very hospitable people. So whenever you have an opportunity, be sure to check out my homeland. So I'm from Uzbekistan, Tashkent. Currently, I'm working at Danish fintech company called Viabil. I'm also organizer at the GDG Tashkent, which is Google Developers Group, and I have founded also Flutter Uzbekistan community. So we organize a lot of events about Google technologies and Flutter specifically. Hopefully on 20th of March, we'll have like offline event for Flutter Engaged to celebrate Flutter 2.0. So enough about me. This is our agenda for today. We will see what are the widgets, what widget types there are in Flutter. Then we'll look their lifecycle and briefly talk about the app lifecycle itself. So the first thing that you will hear or know about Flutter when you discover it, it will be in Flutter, everything is widget. And the second thing that you will probably know is that in Flutter, there are stateless widgets and stateful widgets. But actually, there is one more type of widget, which is called inherited widget. It is used to insert some data or information in the widget tree, and you can pass this information down to your widget tree. But we'll not talk about this inherited widgets because it can be a whole separate talk itself. So we'll concentrate on stateless and stateful widgets. As you probably know right now, the stateless widgets are the widgets that don't have any state, which means they are immutable. So if you want to change them, you will basically reconfigure them, which means that the Flutter engine will redraw with one more time. And in case of stateful widgets, it has mutable state, and it preserves some state in itself, and the widget itself can redraw. So let's see how this state is created actually. So when stateful widget is created, several things happens. First of all, create state method will be called, and it will make the mounted value of the state to true, which means that our state is inserted to the widget tree. And then the first method that will run is init state. Init state will run only on the first initial build of the state. The next method will be did change dependencies. So did change dependencies will run every time when some dependencies will change. What are the dependencies? Dependencies are basically some other inherited widgets that we talked about. So these inherited widgets may be some locale of our app or some theme setups, and etc. After did change dependencies, always build method will be run. Build method is responsible for the actual UI that will be drawn on the screen. So it should return always some widget. There are two other methods that can call the build method. These are did update widget and set state. So did update widget will be called every time some configuration of our widget will change. just like when, with stateless widget. And set state is some manual method to basically enforce our state to rebuild itself. So when our widget is not needed anymore, there are two other methods that will be run. Deactivate is the first method. So deactivate, when deactivate is run, it means that our state is not still in our widget tree, but it's not shown to the user yet. And when the dispose is run, it means that our widget is not mounted anymore, and it's not in our RAM basically. So now when we know the state lifecycle, we can just ask how can I use this knowledge, right? So first of all, let's see when init state, how should we use init state method? Init state method can be overridden so that we can create some controllers, we can create our some repositories or blocks that are needed for our widget. For example, if our screen has some inputs like text, if it has some inputs, we will probably need some text editing controllers. So in our init state, we should create them, and etc. So when we create something, we should always destroy it so that our RAM will not be full and our app will run smoothly. So this closing our controllers, disposing them, this all stuff should be done in our dispose method. And you should override this method to dispose all your all your variables, all your controllers, all your blocks, etc. In our did change dependencies, if we override this method, we can use it to run some expensive work, for example, some network fetches, and etc. So another use case maybe, for example, if locale of our app changes, let's say it was English and now it's Greece, we can track this change in this method and run some specific tasks. For example, we can call to our backend and download new translations. For example, from English to it was English before, and now we need Greek translations. So we can do this in this method. In did update widget, as we talked before, it means when we override it, this method will be run when configuration of widget itself changed. By saying configuration, it is basically some arguments that are passed to our widget. For example, its size, right? When the size changes, we can run some animation with this method animation controller forward, and it will smoothly run some animation so that the widget changing the size of widget will show some animation to the user. And also another use case to override did update widget method is when we have some streams and the stream controller change it, we can track this change by comparing the old stream controller to the new one and remove listeners and resubscribe to our stream. And a little bit about our build method. Build method should be used only to draw some widgets. We should always remember that build method can be run a lot of times. Basically, Flutter says that it can preserve 60 frames per second. So we can imagine that in 1 second, the build method can be run 60 times at least, which means that in the build method, we should not run any heavy tasks because, as you can imagine, this heavy task will be run 60 times per second. So the golden rule is in our build method should be responsible only for drawing some widgets, drawing the UI part. Now you can ask, what about app lifecycle? Maybe if you come from Android or iOS background, you can ask, what about like on create method, on resume method? How can we track if the app is minimized or it is closed, right? we can do it easily. We should just mix in the widget binding absorber to our state. What is widget binding absorber? It is basically a utility from the Flutter engine that we can use to track these like events, right? The on resume or on close, etc. So for that, we just mix into our state with the keyword with, and then in our init state and dispose, we should add observers. After that, we can override the new method, which is called did change app lifecycle state. It basically provides the enum called app lifecycle state, and we can easily switch between the states of this enum. So the first state of this enum is detached. It is not that useful because it is run when our widget is being destroyed or it's just being created. So it's not really useful for us, but it is there. The next state is app lifecycle state inactive. This state is more useful because it is we can track by this state when the app shows some native views. For example, user was in our app, but somebody called him. And what happens on the Android phone or iOS phone, there will be some notification like bubble pop up, and we can track this state of our app or like basically of the phone in this case. Next two states are more useful because these are post and resumed. So basically post state is when the user minimized our app. The app is still running in the background, but like it's not on the main, on the foreground, basically. And when it's resumed, it means that user opened back our phone or our app. So how can we use these states? For example, let's imagine our app needs some lock screen, and when user minimized our app, we should kind of have some 5 seconds. And after this, if user did not return in these 5 seconds, we should show lock screen again. So we can easily do this task using this method. We should basically add to our app this widget binding absorber mixin and override this method and use cases app lifecycle state post and app lifecycle state resumed to do this task. Basically, this was what I planned to talk today, but as I can see, a lot of you guys are not really familiar with Flutter, so I would like to show one of my old projects that I showed during other talks. This is one sample app that I created. It uses the board API. I don't know if you are familiar. So it's some simple API to return some string which represents some ideas what you can do right now. So you might see right now. If you notice, this is the Chrome. This is Chrome. Oh, something crashed. So I will run Flutter web. As you know right now, Flutter can run basically anywhere where there is a screen because Flutter renders everything by its own. Let's hope it runs now. So this is our Chrome. And this is basically our app. So when I press this bulb, it just goes to board API and fetches some random string. So it says learn how the internet works. We also have another screen. We can choose some specific activity by some category, for example, education, etc. Yeah. So as you can see, this is the Flutter web app, but it can easily be run on Android, on iOS, or even on macOS, Windows, everywhere. it is responsive, etc. Some tips if you want to learn Flutter. So I would like to say that you should learn some basics, because it's always good to know how the engine itself works, and it will help you, and it will surely help you in your further work. And also, the next tip is understand the reactive programming paradigm, because Flutter is based on this paradigm. Reactive programming, in simple words, is based on declarative approach and event-based like programming. What it means that, for example, one event can happen in one place, but different places of your UI can react on this. And at first, it will be really hard to reconfigure your mind to kind of understand this. But when you understand this, you will basically understand how Flutter, what can you do with Flutter. The next tip is learn from mistakes, because but you should never give up. Like you should always go forward, move forward. The next tip is read the manual, because the manual of the Flutter is considered as one of the best one, and I can also agree with that. And lastly, keep fluttering, because Flutter is really awesome. We can do a lot of with it. Yeah. Thank you very much for having me. It was a great pleasure.
Thanks a lot, Ulrich, for the presentation. So it's Q&A time, I think. Thanks, both of you. And whoever has a question, just open the microphone and ask whatever he wants.
I have a question to.
Hello. Can you hear me?
Yes.
Sure.
Yes.
I have the question to ask, not about the architecture, about something entirely else. When you are designing for a specific platform, let's say iOS, you have to follow some design guidelines, correct? However, what happens when you try to write a cross-platform app using Flutter? Almost all tutorials use the material design, since it's proposed by the Flutter itself. How does Flutter conform to the design guidelines of each operating system? Does it always use the same designs, the same icons, the same, let's say, buttons?
That's a really good question. I don't know, Ulrich, if you want to take that, or I can take it.
Yeah, you can take.
Okay, thanks. So yeah, as I mentioned in my talk, there are two libraries currently that implement the different specs. So there is the Cupertino library and the material library. Most usually you could run the material library because the spec is more solid, because it wasn't designed only for a single thing, but for a more broader, let's say, design system. But nevertheless, you also have Cupertino icons. So what you can do, you can actually detect if you are in iOS or if you are in Android. And you can add to the widget tree the appropriate widget, I mean, the Cupertino widget or the material widget. Nevertheless, you can have a material widget appearing as a Cupertino widget, which is most usually what we are doing, because they are very, very much skinnable. So it might be like material, but you can make it appear as it is in iOS. The thing is, so if you want to, let's say, adhere to the specs of iOS, then you might want to to think about how your application in the different platforms you want to appear. If you want to adhere to Cupertino for both iOS and Android, then you use the Cupertino library. If you want to have different approaches according to different platforms, then you have a lot of switching between the different components. So you have to render different things. But the most common approach is that you create a look and feel that is cross-platform. What I mean is that, let's say that you are, let's say in the case of our application in Ping Pong, we have something that looks a lot like Cupertino, but it's not 100% Cupertino. But we want to look like that in both Android and iOS. And that's the easiest thing that you can do, because what I am doing is, because Material Libraries has it had received a lot of love, let's say, from Google, and Cupertino Libraries has fallen a bit back. It's the usual thing is to use Material Library and make it look to whatever spec you want to have. Maybe you want to have the same design across platform, and that's the most usual, actually. Because if you don't have, because then if you want to have different look and feels, in my opinion, maybe you should look into having different applications, because it will make your application a lot more complex. Every time check to see if you're in Android or iOS and present the different widget according to the platform. If you have to do that in every single widget, then there is no point in creating a single code. You can just have different native apps and be content with it. The power of Flutter comes with, let's say, minimize having the common denominator as high as you can have it. I don't know if I answered your question or if there's something more.
I really did. One more question, if I may. Are there any other UI libraries apart from Material and Cupertino?
So if you remember the slide that I showed with the layered architecture, you would see that in order to create one of those libraries, you have to use a lot of lower level code. And this is work that no one wants to do. I don't know of any other library apart from Material and Cupertino. There might be there. I don't know any other, because Material is more than enough to create whatever you want.
There is actually a library on the Flutter 2 presentation. They showed canonical guys. They created Ubuntu library, like specifically Ubuntu widgets, so that they match Ubuntu specs.
Yeah,
and also
and
also I saw the Windows 95 UI component. Yeah, it was kind of fun project that community did.
Yes.
But yeah, the idea is that you can always create your own design library if you want, if you have time and power.
The thing is that because it's themable, so you can create a theme of your own running over Material, and that might take Material and looks nothing like Material.
Totally.
Okay, thank you.
Thank you. Good questions.
I have a question about ping pong.
Okay, sure.
I saw on the website that you have Windows, macOS apps. Are they done with Flutter too?
No.
Oh.
No. The desktop platform are not there yet. I mean, it's really good in Linux, just because the Flutter guys always use Linux machines. So they're very like comfortable using with working with this platform, and this comes straight from the team. But you know, Mac OS and Windows, definitely Windows. No one really wants to dwell in that territory. But we're using Electron for that. So the thing is that you can. I believe that there's no single tool that solves every problem. In my opinion, Flutter is best used in mobile, and when the desktop port comes to like stable, maybe in desktop. Using Flutter for web, you can, in my opinion, you can do it only if you don't want to, you have a mobile app and you don't want to deal with, web development. You just port that to the web and you have a web app as well.
I have a question. Hello.
Hi, Zoe.
Okay. First, thanks Efthimi and Ulukbek for your presentations. They were very interesting. I learned a lot. As far as I understand, there are many pros. You mentioned the hot reload, the widgets, everything is a widget, the single code base, the built-in Cupertino. And my guess is that in terms of productivity, it's a good fit for any programmer, and in terms of performance. And I think that from what I've heard so far, it really fits well with IoT as well. And I've heard a lot of pros. And I was wondering, what are the drawbacks? We didn't hear any cons on that. Why shouldn't we use Flutter?
That's a good
Except
question.
for the desktop that you mentioned earlier.
Yeah. So that's a good question. So yeah, for me, if you want to create a web app, don't use Flutter. If you want to create something in the desktop, right now, maybe it's avoid the pain and don't use Flutter. But if you want to use it for something like a mobile cross-platform or IoT, for IoT, there are a couple of ports. It is a bit of pain to do it, but they're getting better. I know that Google Home, the one with the screen, it runs Flutter. So drawbacks. Let's stick to mobile. If your application is something that has to deal a lot with native code, meaning that your code is going to be in plugins like more than 50%, let's say, or 40%, then maybe it's a good idea not to use something like cross-platform and implement it natively for like having two code bases. This makes sense. If you have something like, I don't know, something that could run for a map app, the plugin can provide you with certain things, basic, but at some point you might find yourself trying to implement a lot in native Android and native iOS. So when this implementation hits a critical point, I think it's and you have to assess that beforehand. It's not a good idea to use something cross-platform and like something like Flutter. Other than that, I cannot find something like a drawback. Maybe a drawback could be that the plug, because it has attracted a lot of hype and there are a lot of open tickets, there is a tendency to take a long time for something to land in the master branch and then go to stable. But that's something that happens to every very big project. Yeah, I don't know if I answered your question, Joy.
Yes, sure.
I'd like to add to this. So if we talk about where to use Flutter, I can say that for web is much more stable than the desktop. But if you want to create some website that is dependent on SEO, right, that is dependent on crawlers, then Flutter is not the choice. Flutter might be choice if you want to make some dashboards or some real PW applications, and for mobile also. But there is a big but as of now, and it's related with our iOS. So I should be honest, if you really want to come to Flutter, there is a bug with the Metal engine on the iOS. So basically, before, when Flutter first launched on iOS, there was iOS was using OpenGL, but then they moved to Metal on iOS 14, I guess, if I am not mistaken. So right now, what happened to Flutter is that there is a big animation janks before the Flutter engine kind of warms up these shaders that are used in Metal framework. So because of this, there are a lot of developers that are frustrated with this bug, and a lot of hate to Flutter actually from kind of other developers like React Native guys and others. So yeah, this is the bug. This is the big bug that is currently we have. Flutter knows about it. Flutter says that they are working on it, and we all hope that it will be resolved soon. But yeah, this is that you should consider if you want to really like launch some startup using Flutter or etc. There are some workarounds, and probably you will need to implement them as of now.
Thank you both.
And that goes for animation, right, Ulrich?
Yeah. That's
so if you don't have any animation in your app, you're okay.
Yeah. But still, there are animations like when you open the new screen, and even on this animation, there are some janks.
Yeah. So about yes, the team is aware of the frustration, and they're working. We had a meeting with Eric a while back, and he was very aware of what's going on. But the thing is that it's a problem with the shaders, so it's kind of like a very complicated problem. So
yeah, we all hope that it will be resolved soon. But yeah, well.
Anyone else?
actually, I have hot reload working now. I don't know if you want to show you guys what you missed.
Of course, we need about a couple of minutes to prepare the giveaways. So
all right, cool. So if can you see my screen?
Yep.
Okay, so I have opened the same app
Yes.
in emulator in Android. So this here works. So if I want to change the primary swatch, let's say to, again, redlet, and as soon as I save, they run hot reload and it's just there. And if you can see, the state didn't change. And the state didn't change just because the state remained the same in the element tree. It didn't change the widget in the element tree. It changed only what it wanted, what it needed to change, which is only those two components. Let's say I want to change the icon, and I can I don't know, put like a +1, and it changed. So it's that fast to develop something when that works, of course. I don't know. Yeah, that's what I wanted to present.
May I ask something a little bit irrelevant? No. Can you create an iOS emulator without actually having an iOS device?
Yeah, that's $1 million question, right? Yeah. So No. The thing is that you might be able to have something, but it wouldn't be right because it needs Xcode in order to compile the code and push it to the platform, which is the iOS simulated. So you cannot do that. But having said that,
no. I mean, if you have a macOS device, for example, a MacBook, a laptop, but you don't have an iPhone or an iPad, can you create an emulator?
Yes, that's the simulator. Okay, let me just demonstrate that. Let me close the app here and close off this emulator. And if I want to, I can go over here and say, okay, run it in Chrome or run it in iOS simulator. If I do that, it will open up the simulator and will run the app there.
Screen, if you...
Oh, yeah. It's 2021 after all, right? Okay, so I'm sorry, let's go over again. I close that and I can select any of those. I can select like an iOS simulator and we'll just open up the simulator, which is an application in macOS that simulates the iOS environment with some limitations.
So in order to be able to build the actual application for a Mac, for iOS, you actually need a Mac OS device.
Yes, you need that. But what you can also do something else. You can develop in an emulator and develop in Android, and then you can use one of the services that are out there, CI/CD services, that can actually build an iOS build for you and ship it to the App Store. So you can actually ship something in iOS with the asterisk that it's not tested. You can ship it to the App Store via a CI/CD service. I know CodeMagic does that. I know other services are starting doing that as well. So you can actually ship it without having a macOS.
Okay, I think that was more of a question about the Mac and iOS than a Flutter. Thank you.